In today's talk, I'm going to be discussing how artificial intelligence is being used currently and some of the big areas in which artificial intelligence might be able to change how we do work or change how certain roles or industries potentially function. I'm then going to be talking about some of the debates and criticisms surrounding artificial intelligence. Now, this video is going to build upon the previous video in which I talked about what AI actually is and some of the key terms and ideas in artificial intelligence. So I'd recommend that you watch that one if you haven't done already. But just to recap, the basic point of that is when we're talking about artificial intelligence, we're not talking about machines that are going to take over the world and subdue all of humanity. We're talking about computer programs that seek to simulate some part of human intelligence. So computer programs that are able to do things that humans can do, or even in lots of cases, do things that one human couldn't do, or even if a group of humans could do it, it would take a long time, whereas a piece of AI can do it very quickly. So first of all, I'm going to talk to you about some of the fields in which AI is being used and researched, and where it could really change how certain things are done. So if you would like to be a bit involved here, why don't you pause this video now and have a talk, if you're with someone or if you're on your own, just write down some areas where you think maybe AI could really change the world or solve or help to solve some of the big problems or issues that we face. So if you want to do that, pause the video now. Okay, well, moving on to my examples, I've picked 3 areas. There are lots and lots of other areas that you could look at, but to keep things focused, I've just picked 3. So first of all, health and diagnostics. So there's lots of ways in which medical profession is looking at incorporating artificial intelligence into medical practice and research, because it could have lots and lots of effects. So first of all, AI can be used by doctors when they're diagnosing a disease. So when doctors are trying to work out what might be wrong with someone, they'll look at lots of different things. They might look at images from CT or MRI scans. They might look at results from blood tests or other tests that they've done. And sometimes these things can be quite hard to do. If you think about if you've ever broken a bone, or a doctor's thought you've broken a bone and they've taken an x-ray, it's quite hard to read x-rays. There are doctors who are trained specifically to be able to do this, but even so, when you're diagnosing a disease, it can be quite difficult for doctors to pinpoint something or to do it early enough. Now, if we think about a disease like cancer, the earlier that cancer is diagnosed, generally the more chance that doctors have being able to stop that cancer and remove it before it harms the person more than it already has done. Now, cancer diagnosis is one of the areas in which artificial intelligence can be used really effectively. You can use computers to scan or look at scans. You can also look at computers to look at all sorts of results that doctors have taken from doing tests on someone. In some cases, artificial intelligence can diagnose diseases earlier or more quickly than doctors could do, which obviously is really good news for patients in terms of working out what's wrong with them and hopefully getting the right treatment. Now, a computer couldn't do everything. A doctor would still be very much involved in terms of deciding what treatment might be best for someone, also in terms of involving that person in their own healthcare experience. If you think about it, I think it would be quite, it's very frightening if you were to suspect you might have cancer, and to get that diagnosis from a computer, I think, would be really impersonal and much more upsetting than if a doctor would tell you that information and you'd be able to have quite personal conversation about it. So it's not that doctors could in any way be replaced by machines, but it might be that AI can do some things quicker than a doctor could on their own. Now, on the kind of other end of medicine is medical research, which is looking for new cures, vaccines, or treatments for things. Now, obviously, there's lots of discussions at the moment about finding a vaccine for COVID-19. Now, when doctors are trying to come up with new medicines or treatments, they'll look at old sort of medical research, treatments that might have used, and they'll use that to decide what medicines they might try and explore, what sort of chemical and biological compounds they might use, and then also in terms of how they think people might respond to that. So, when we tested a very similar drug before, how did someone respond? Or when we knew that it was a real problem that it made them feel sick, so maybe this drug might also make them feel sick. Now, artificial intelligence can do that a lot faster. So artificial intelligence can run through machine learning the results of loads and loads and loads and loads of tests and look at kind of previous medical research where that's got to try and identify what types of drugs or compounds might be successful in treating a particular disease. And then also artificial intelligence can then model how a human might respond to that drug. Now, you still need to do tests on animals and on people. It wouldn't be the case that a computer would say, yep, this drug will work, and then doctors would say, okay, let's just start giving it to all the patients. That wouldn't be safe. But artificial intelligence and that kind of computer modelling can be a really good way to help medicine move a lot quicker than it would do otherwise. On to our next example. Facial recognition. So this is where a computer or any kind of piece of computing, so even a phone, if we think about sort of the new facial unlocking on very modern iPhones, so a computer can kind of recognise or identify who a person is, who that face belongs to. And this can be used in lots of different ways. So the way that facial recognition works is that computers map lots and lots of points on someone's face and then can match the image that they scan to lots and lots of other images on whatever databases they can access. So if you think about if you go through an airport, there's someone at passport control who you'll give your passport to, and they will look at you and look at your passport and check that you're the same person. Or if you've got a biometric passport, you'll go through a scanner where that is all kind of scanned and done sort of a lot more automatically than going up to a person. So facial recognition is a bit like that, but used in lots of different settings. It can be used in banking or in anything that's online that might be very private or sensitive. For example, if you want to set up a bank account, now some banks will allow you to do that all online. What will happen is that you will record a video of yourself talking or take a photo of yourself. You'll then need to scan your government ID, so that might be your driving licence if you drive, or it might be your passport. And then the system will check that those two match, that you are who you say you are. This could be really useful in lots of different situations. For example, at the moment, people might not want to go out so much, but they might need to access banking online, or they might need to set up online banking if they don't already have it, and this could enable them to do that. And also, people might not live near a bank. If you live in the countryside, or if you live somewhere where there just aren't that many banks, then this could be a really good way of allowing people to access banking without having to physically go into a bank. Facial recognition can also be used for security. So for example, it could be that if someone was banned from a shopping centre because they've been caught shoplifting, the security system would upload a photo of that person, and then the CCTV system would kind of be constantly scanning people's faces, and if the computer said, well, there's a match here, we can see that this person who's been banned is coming in through the kind of west shopping door, then security could go and identify that person. It could also be used potentially if the police were trying to hunt down someone, and they could kind of get the computers to be constantly going through live criminal record databases or any other kind of data sets of lots of people's faces and scanning anywhere where there's CCTV to try and identify someone. So again, not totally different to what happens with CCTV now, in that in some cases people will be looking through CCTV trying to find someone, but obviously a piece of artificial intelligence can go through thousands of cameras and thousands of images very, very quickly, whereas you couldn't get humans to do that unless you had lots of people and lots of time. Now, my last example of where artificial intelligence could be used. Last example is modern warfare. So drone technology or remotely controlled, there's not always a kind of a TV remote, but remotely controlled weapons or autonomous weapons can be used in warfare. And what this allows armies to do is it allows them to attack enemies wherever that might be, or sort of target buildings or areas that they're targeting, but without risking troops and without risking fatalities of their army. So this can be a good way to send kind of machine craft somewhere where they think there might be a bomb, to test out if there is a bomb there without risking soldiers' lives. It might be a way of conducting warfare in a kind of potentially cleaner way for the army using it. Obviously for the people being sort of targeted, it's not necessarily cleaner, and there's still obviously a risk to them. But this is one way that might really change kind of that view of war that we might have from the world wars, of sort of trench warfare, of actually lots of warfare can be done with very few soldiers involved. And there's obviously a saving there, that you're not sending thousands of troops somewhere. You don't feed them, you don't have to give them somewhere to sleep, you don't have to have all of that infrastructure set up. But on the other hand, these machines are really, really expensive. They're also quite sensitive. You also do need highly skilled people in the army operating them. And like we talked about in the last video, you need that human in the loop. So it might be that sort of drone technology has identified what it thinks is an enemy building, is in the right area and the right kind of size and shape, but then it might be someone operating that drone or reviewing that drone before anything is done and can identify actually it's a school, it's not a building that should be targeted. So it is important that there are still humans involved, so that if something is done that is wrong in war, or if civilians are harmed when they shouldn't be, that there's someone held accountable. In that case, having that human in the loop making the decisions, make sure that we do have that accountability. I'm going to move on now to look at some of the potential problems with AI, or some of the criticisms that people have about artificial intelligence. First of all, privacy. We don't always know where our data is being used. If you think about the recommendations that we looked at in the last video, Netflix saying what you'd like to watch next, or Amazon recommending things that you might want to buy. You'll see this a lot when you're kind of shopping online, that you look at something on one website and then you're going to a totally different website, but you'll get adverts for that thing you were looking at potentially buying. And companies want to buy our data to use it to model things. Insurance companies want to be able to model and predict how people will act. Lots and lots of different companies want this. So the more that our lives are lived online or are trackable, the more that companies want to buy and sell our data. And often people don't realise that our data is being used in that way. So even though it might technically be legal, it might be something that we've signed up to. If you think about the last kind of few things you've signed up to, that you've had to create an account for, or when you've got your phone, do you look at the terms and conditions? Probably not all of the time. And as we get more and more used to setting up accounts online for this and that, we definitely probably get a bit more slack about that. So we don't always realise that by signing up for one thing, potentially our data is being sold or given to a totally different service or company. And because companies can make lots of money from our data, and there's also something a bit questionable there, because often we sign up to free services, but the company is profiting off us signing up, and potentially there's an argument there that we should be being paid for our data, or we should be more careful with what is a very, very valuable asset. And then lastly, if we think about facial recognition, it might make it almost impossible for us to be anonymous. Yes, there's already CCTV, but the people looking at CCTV don't know who we are normally. Whereas if facial recognition was used as a matter of course by, say, the police, we could constantly be tracked. And you might say, well, if you're not guilty, you've not got anything to hide. But what if we lived in a dictatorship? What if we lived in a regime that was really discriminatory against certain groups of people? Then this kind of tracking could be used in a really oppressive and dangerous way. And people might also argue, even if we don't live in a dictatorship, that actually there's something very, very intrinsic and important about a right to privacy that means that governments shouldn't do this, because we have a right to be anonymous. We have a right not to always be tracked, because there's something very, very precious about that privacy. The next area that is sort of quite contentious within artificial intelligence is bias. So artificial intelligence can entrench existing biases. So an example of this is predictive policing. Now, the way that predictive policing works is that you can upload all the activities of the police in an area over the last, say, 5 to 10 years, maybe longer. And then the computer program will do lots and lots of modelling and suggest where police should focus their resources, where there seems to be the highest level of crime, and therefore where the police would be best placed to focus their efforts to stop that crime. There are, however, some problems with this. For example, there's lots and lots of criticisms that police forces all over the world have institutional racism. So this could well mean that the police historically have focused on black and minority ethnic areas within the city, and that those communities have been unfairly targeted by the police and potentially even framed for things that they haven't done, and white communities might have been allowed to get away with things. And then if you think about what that would mean that the computer would send more police staff to areas potentially where certain kind of ethnic groups live. And if you've got more police there, you are more likely to catch more crime. Therefore, that kind of re-entrenches that pattern, whereas it might be actually that in other areas there's crime still being done. It might be more kind of white collar crime that's harder to spot on the streets but maybe has a bigger impact, but it might even be that this crime's still going on, but because the police isn't there, they're not able to track it. So it can entrench kind of biases that people already have, but do it on a much larger scale. AI itself can also be biased and inaccurate. For example, this can depend on the kind of data sets that are used. So an example of this is that a company was developing a hands-free soap dispenser. So you put your hand under it and it would recognise a hand was there and drop soap, and it needed to recognise when a hand wasn't there so that soap wasn't wasted. And the company developed this and they sort of tested it on all their employees and it was great. But then someone with a different skin colour tried to use soap dispenser and it didn't work because the company had trained it on data sets that weren't representative. So that was kind of a problem that was built into the artificial intelligence. With facial recognition, lots of studies have shown that facial recognition is not as accurate for black women. Now, what does that mean? That means if the police are trying to track down a criminal, if you are a black woman, you're much more likely to be wrongly accused, or police say, well, you were here and the machine matched your face, but the machine might have made a mistake. And then on to this last point, it can be harder to question the bias of a machine than a human. If you can't see algorithms, it's harder to say that a computer is biased, because often we think that science is very rational and logical, and it is to an extent, but it's also created by humans who have all of these prejudices and biases. So this can be a problem that's quite hard to challenge. And then moving on from that, transparency. Companies and computer scientists won't always reveal their data sets or their algorithms. So it can be really, really hard to know how data is being used or how decisions are being made by the computer program. So that can be something that's really tricky and makes it much harder to challenge artificial intelligence. To conclude, there's lots of areas where artificial intelligence could be having a real positive impact on society and the world, but there are also some real potential problems with artificial intelligence. So it's really important that as humans we're questioning how it is used and making sure it's being used for the benefit of everyone, and that it is as transparent as it can be, it's as unbiased as it can be, and that we protect our privacy if we think our privacy is important and worth protecting.